Okay, so we are looking at square root functions today. This is the parent function for square root functions. So whenever they ask you to compare a function with a square root in it to the parent function, this is going to be the one you look at. We cannot take the square root of negative numbers and graph it in the real number plane. And so the domain is limited. The x's that can go into a square root have to be greater than or equal to 0. So if they ask about domain, this is what they're looking for. And so this is the numbers that we're going to put in. So for this one, I'm going to do the square root of 0, which is 0. I know, very exciting. Then we do the square root of 1, which is 1. It gets more exciting when we get to here, square root of 2. So on your calculator to do a square root, you hit your second key, and then you hit the x squared key. See where it has the little square root up there. And then we are going to type in 2, and it's about 1.4. And then we can do the same thing for square root of 3, and we get about 1.7. And then the square root of 4 is a perfect square, that is 2. Square root of 5 is 2.2. Square root of 6 is about 2.4. So if it's a perfect square, you'll get a whole number answer. If it's not a perfect square, the answer is irrational, but to graph it, we're just rounding those decimals off. So we are only in the first quadrant because everything's going to be positive. So we have 0, 0, 1, 1, 2 is 1.4, 3 is 1.7, 4 is at 2, 5 is at 2.2, 6 is at 2. I put that one up a little too high. 2.2, 2.4. So it grows really slowly, and then we're going to put an arrow on this end, and that's what it looks like. It curves, starts at 0, so there's nothing in quadrants 2, 3, or 4. It's all in quadrant 1. And so we talk about the domain, these numbers all being greater than or equal to 0. When I put those numbers in and we see the numbers that come out, we also see that our y's are going to be greater than or equal to 0. I am not going to have any negatives for the domain or the range. So I'm just going to put negatives. Now, we're going to move this function around, and sometimes there will be some negatives if we move it from this parent function, but this is what domain and range is for the parent function. They may ask you to define domain and range. So if we look at my domain, the x is greater than or equal to 0, and my x starts at 0 and go up. My range also starts at 0 and goes up. There's no negatives. So this is just shorthand. Okay, so we're going to see what happens when we manipulate this equation a little bit. So when I come over to here and add 3, basically what that means is I'm taking the square root of 0 and adding 3. So that's just 0 and I'm adding 3, so it's a 3. And then we got 1, 1. It's the square root of 1 plus 3, so 1 plus 3 is 4. And then basically I'm just adding 3 to each of these answers. So this is going to be 4.4, 4.7, 5, 5 point, and 5.4. So basically what this did is it just upped all of those y values by 3, which means because we're just adding 3. So my x values are the same, but my y values are 3 units higher. So I'm going to start at 0, 3, 1, 4, 2, 4.4, 3, 4.7, 4, 5, 5, 2, 5.4. So it's going to have exactly the same shape. all we did was shift everything up 3 units. So what that means is my domain's still the same. I can still put the same numbers in because my x values are still greater than or equal to 0. My range, my y values, there is nothing below 3. You see how it starts at 3 and goes up? Or I can table 3 is the smallest number that I have for y. So my range now is y is greater than or equal to 3. I don't know why I just wrote 0, because I was looking at that one. So my x's start at 0 and go on to infinity. But my y's now start at 3 and go on to infinity. I know, super exciting. So, some of them are going to be if they predict, some of them are not. So on this one I have minus 3, but it's inside the square root. That means I'm taking the square root of 0 minus 3, which is the square root of negative 3. Can't do that, so that is both, so it's kind of a dash there. So we'll try the square root of 1 minus 3, that's the square root of negative 2. Can't do that either. If you try to do this on your calculator, let's see it. The square root of negative 3. I'm in the wrong mode for that because juniors are actually in real mode. And try that again. So we're gonna say this error non-real numbers. So this means basically we can't do it in graphics. So if we keep going, where does this stop being negative? We get 3 minus 3, so square root of 0 is 0. And I'll have the square root of 4 minus 3, which is the square root of 1. Make 1. Square root of 5 minus 3 is the square root of 2. And these are going to look familiar. And have 1.4, 1.7. And you can keep going to have more points, but the is going to be as others. So now my graph is starting at 3, 0. I get 4, 1, I get 5, 1.4, I was supposed to be 1.7, or 1.4. So we can put more points in there, it keeps going. The shape has not changed. It's taller, it's not fatter. It's just been moved right 3 units. If I told you this subtracting 3 was gonna make it move right, it was kind of counterintuitive. We think about subtracting as being a left face, you're subtracting from the x before you do the other. So, so I ask you, what is the transformation from paragraph? This is what they're asking for. So transformation from paragraph is in a if we ask for domain, we could not put in this section. The only numbers we could put in were 3 and 4. So my domain now is x greater than the graph you can set as 3 to infinity. My range starts at 0 and goes up. So I can say for the range that y greater than or equal to 0. The numbers that are getting as output. Early. Terribly exciting. Okay, so I have a negative from the square root effect. It's not inside, it's on the outside, so this is different. And if I involve in it, we'll secure the side. What that's gonna do is it's gonna change size. Negative doesn't do much. But negative square root of 1 is negative 1. Negative square root of 2 is also negative 1 whole 4. Negative 1.7. Basically, cutting numbers off my graph, everything is now gonna be negative or 0. So, we have a slightly different graph. This is now the axis. My axis, we can see negative. So, 0, 0, 1, negative 1. 2, negative 4.4, 3, negative 7. So what happens to graph? Remember comparing it to that parent graph. So it flipped, right? It flips up and down. So when they have a transformation, the method they're gonna use is it flip it over x-axis. So this axis, it was up here, it flipped over, now it's down here. Which makes sense because all the numbers made all the y's, so my domain is gonna be x squared than equal to 0. And my y values are 0 and less. It's gonna be less than or equal to 0. Okay. We'll take a break here. We'll want to do a little more. And this is a lesson. In the next, we put the negative on is. So, square root of negative 0 is over is fine. But when I try to take the square root of negative 1, that's what the calculator is going to start giving me my answers. So I can put in 1, 2, 3, 4, 5. This all can be a but. So what I'm going to do is I'm going to change this input to be negative. So I'm 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Because then that negative will cancel out. Since a 0 is fine, but off negative 1 will just square 1. Just square root of negative 2 is the for 1.7. So all the numbers are used to this be 2, 2.2, and this be 4. So what's gonna happen now? We're gonna have negative 1, negative 2, 1.4, 1.7, and it's now going off this direction. So if I compare this, that you can tell that's the same day. It's just over here. The parent graph is now over here. So how do you say that? Yeah, you can say that is reflected, reflection, either way, over the y-axis. So the